Okay, okay.
Yeah, it's great.
Okay, so hi everyone, and welcome to today's Fred Jelinek series seminar. I have the honor to introduce my friend and our honored guest, Professor Stefan Ultes, who is a professor of natural language generation dialogue systems. I'm not sure which order.
It's also on the slide.
Oh, right.
If you don't remember.
Right.
But it was the right order.
At the University of Bamberg, and he was previously also in Cambridge in Professor Steve Young's group, where he was working on dialogue systems, and that was like the group that kind of set the pace for everyone for dialogue systems at the time. And then he spent some time in basically in the industry. There was Daimler, right?
Yes.
So there, and now you're here. So I'm very much looking forward to what you have to tell us about dialogue systems, and I suppose you can take over from here.
Thank you very much for this very nice introduction. Hello, everybody. I'm very honored to be here today to talk to you about, it doesn't really fit into the sentence, I will say it anyway, to talk to you about towards the natural behavior of dialogue systems with explicit dialogue control. It's a rather long title, but I tried to squeeze everything in there, and I think that I did it quite well. It's always good if you think of you well. Okay, so my home base is Bamberg. It's in Germany, and I'm pretty sure most of you don't know where Bamberg is. So to help you a bit there, Bamberg is this blue spot here. I can use the pointer. The blue spot here, this is Prague, this is Frankfurt, this is Munich, this is Berlin. And this is basically the path I took yesterday to come here. And I'm very happy to be here. Bamberg is a very nice place, very nice city. It's very old buildings. It's actually UNESCO World Heritage for its medieval city center. So if you ever have the chance to come to Bamberg, don't hesitate and give it a visit. Another thing that Bamberg very famous is for is its beer culture and its beer. So I also want to point out that it's actually the region in Germany or even in Europe with the highest microbrewery density. It's really like that. If you go from one village to the next, you're going to find at least one other brewery. Sometimes they even have two. So if you're into these type of things, it's a very good place to be. Of course, also what comes along with that is the relaxedness of people and the easygoing lifestyle. Okay, that's the end of the advertisement block for Bamberg. I will continue with the advertisement block of the university. So it's a rather small university. I think it's only probably a fourth or a fifth of Charles University size in number of students. We have 4 divisions. Most of them are non-technical, humanities, then economics and social sciences, human sciences and education, and information systems and applied computer science. This is the newest division where my group belongs to. Has been established only 2002, so it's rather new. If anyone or any student might want to visit Bamberg, there is a newly established Erasmus exchange program between Charles University and Bamberg University on the undergraduate and graduate level. And we do offer many courses in English, which unfortunately is still something you need to emphasize for Germany. But we do have that. And if you are interested or anyone is interested, they should look into this. I think it would be a very nice stay there. Okay, now also the university advertisement block is over. And I'm continuing with myself, my group. I joined Bamberg University in 2022. Before I was at Mercedes or Daimler. And before that at Cambridge, as Andre already pointed out. And the focus of our group is natural behavior of conversational agents. We want to research on that topic and I will be a bit more specific on what that actually means. But it's about the behavior of the agent. Some topics that are included there are neurosymbolic dialogue systems, reinforcement learning for dialogue systems, and controllability in large language of large language models. Probably better term. The group is rather small still. We have 4 people, but we are currently looking into how to get more funding and grow the group. Okay, so what do we mean with natural behavior of conversational agents? If you look at how systems build or how conversational agents build, they need to do 3 tasks. One is to understand what the user says. One is to decide how to continue. And another one is to figure out how to form this decision into a reasonable response. And traditional systems were doing all of these things separately in several modules. More recent systems that use LLMs or are just LLMs, they kind of do everything in one go. But still, I mean, you can still think about those separate tasks that needs to be done to get a good interaction between a system and a user. And the goal is that we have such an agent so that the user thinks about the interaction, that it's effortless, it's smooth, it's natural, without further specifying what exactly natural means. I think that's a very objective, subjective term. And if you ask many different people, you hear different definitions of that. I think it's in some way related to the question of what type of behavior do we expect from such a system? Is it the same behavior as we expect from humans? Or is it more something like, we know it's a technical system, so we also have other expectations. In some regards, maybe higher expectations. In some regards, maybe lower expectations. Whatever it is, that's unclear, I think. To me, at least, I think many people have a good answer to that, which is you should mimic human-human interaction. I'm not so sure that's always the case for all situations. And this is what we try to do research and to find out what that actually is. And there are so many different things. What you can influence in terms of decision-making. The decision-making component plays a crucial role from our point of view in the behavioral aspects of a dialogue system. And you can, there are many things that can be influenced by the decision-making component. Of course, the response type, is it a question or is it not a question, or on a very high level? What is the content? What content should be conveyed to the user? What wording should be used? What linguistic style? What communication style? Acoustic style? And so on and so forth. And I think this can go on for a bit. And it's also not clear necessarily where the boundaries are between those categories. And this doesn't mean that all of this needs to be modeled explicitly, but this is just things that can be influenced by a decision-making component. And this is even more difficult as we don't only have the textual context as we have in large language models, but we also have additional information like user characteristics that play a role there. The system role, why is the system there? What's the task of the system? Maybe the system is endowed with some personality that can play a role there. What's the environment this agent is operating in? What's the situation, the setting? Everything is set. And all of this also entails the idea that an agent usually has some idea, some purpose, some plan, some intentionality of what to achieve, which is something you also find in humans. I would argue that humans have, when they interact with people, they do have this type of idea of why they are doing this. Might be entertainment, might be to get something done, might be both. There's definitely a multitude of opportunities here possibilities. And we also think that a conversational agent needs to have these things. Yeah, and today I would like to argue why it's necessary for having a naturally behaving conversational agent, why to have explicit dialog control there. And let's see whether I will be successful in the end, whether you kind of can follow my argument or whether you are not agreeing with what I'm saying. I would be very happy to have a discussion about that then. Okay, first I will talk a bit about some work one of my PhD students did a while ago on communication style analysis. And then I will go even farther back during my PhD times where I worked on, or even also postdoc times where I worked on dialog policy optimization, reinforcement learning, where we were still operating in the modular dialog systems world, to show that even in very simple setups, different behavior can make a difference in how the interaction is perceived. And the setup was really easy, was an easy dialogue problem. And then I will talk a bit about our current research and future research, what we are want to do with this and why we think, or what type of explicit dialog control, what we mean with that. Okay, communication style analysis is something that can have many forms, or communication styles can come in many different forms. We specifically looked at elaborateness and directness. How can you imagine that? So to the user question, what is the weather today like? There are many possible options that may or may not convey similar content. We had two axes, basically, a directness axis and elaborateness axis. And an elaborate direct answer would be, it will be cloudy mostly and it might not rain during the afternoon. And while the concise answer would be, it will rain. Hopefully not in Prague, but in this example that was the case. More indirectly speaking, a concise response might be, you should take an umbrella, kind of hinting that this might be necessary because you might get wet otherwise. And an elaborate answer would, I would propose to take an umbrella, a scarf, and gloves would be good as well. Just to make clear what the options were and how to interpret elaborateness and directness. And Juliana Almeida, the PhD student who finished 2022 already, she did many analysis, many work on this and came up with this dependency graph. I will not go into all the details here. There are three main findings. One is that the user preference of system communication style depends on user traits and on the system role. So there is a dependency between the role of the system, the characteristics of the system, and what type of communication style people prefer over a conversational agent. So this clearly says that one type of behavior doesn't fit all purposes, all user groups the same. It's more individual. The second finding is varying communication styles affect the user satisfaction and behavior. And the third finding is the communication style of the system is influenced by the preceding communication style of the user. So it's not only specific to the user themselves, but also to the actual conversation. So it's even more fine granular in its requirement for adaptation, if you will. I will illustrate a bit what we did to make clear where those findings come from. The finding one is that the user's communication style depends on the user's culture. It was one of the findings. And there was an experiment done between the same one with, it was conducted in Germany and in Japan. And then the people were asked how they liked the conversation styles, whether they prefer the direct conversational style in this case, and there was a significant higher agreement from the Germans that the direct addressing the problem was preferred, and the Japanese people liked it less, which clearly indicates that this is that there is some cultural dependency. It's of course just one single finding, but if you extend this is definitely true also for other aspects. Another study Juliana was working on is the role, whether the system role depends on what type of conversation style people prefer. And there were three options. The social companion option, the dialogue was kind of representing an agent that was meant to be a social companion. The second one, the dialogue, called the conversational agent, was an expert for a certain healthcare topic. And the third one was a personal assistant. And depending on the role of the system, the communication style also varies. So it's not like a personal assistant should behave the same as a social companion or the expert. And this was true for the elaborateness and the directness dimensions of this. I will skip finding 2. It's not that important for the point I'm trying to make. Finding 3 was that the communication style of the system is influenced by the preceding communication style of the user. For this, human-human interactions were analyzed where one of the humans was kind of acting as a system, and there was some correlation identified. Of course, it's not the strongest, correlation, but you can definitely see that there is some influence from the communication style of the user towards what is preferred by the system, or what the system chooses in this human setup. Of course, there are other work that looks into communication style that even kind of broadens the dimensions that we need to think about when we want to create conversational agents. What can or needs to be influenced one way or the other by a decision-making aspect of a conversational agent. They already found out that the question style influences the response style. So if you the response kind of picks up wordings and style from the question being asked, which should not be to anyone's surprise. I think you all have noticed that already, but this is has also been looked at from a scientific point of view. Also, that if you have spatial references or talk about objects in the physical world, that there is some adaptation going on, some type of lexical entrainment, if you will. They kind of agree on how to refer to. People agree when they talk to each other on how to refer to different objects or how their position in the room. And also, there's even more. There's an even deeper finding from Niederhofer and Pennebaker of 2002 that there's even some low-level coordination going on during the turn-taking and also for the overall conversations on who says what when. It's more like they describe it like a dance. They compare it like to a dance, that there's some coordination going on that's even more profound than just doing the back and forth turn taking. So we see that just looking at communication style, interaction has many different aspects that need to be taken into account when we want to build a conversational agent for different situations. It's highly adaptive towards the user, towards the system role, and many other things. And this is really complex dimensions are kind of offered here that needs to look into to have a natural behavior of a system. So all of these things potentially need to be addressed for natural behavior. Now I want to continue with work I did on dialogue policy optimization through satisfaction-based rewards, showing you that even in simple settings, the naturalness of the system behavior can be improved by making the right decisions. There are two parts to that. One is the user satisfaction reward estimation, and the second one is a dialogue policy learning to give you the full picture of what has been done here, to have a better understanding of why I'm making these conclusions. So this is still the old world of having a modular dialogue system. 2017, 2019. We have a speech recognition and a speech synthesis for the speech level. Then we have semantic decoding, which is like the NLU, NLG here, and the belief tracking and policy kind of build the dialogue manager. Or if you will, the belief tracking is kind of an NLU on the dialogue level. There are different views on that. And the idea is to kind of extract information from those modules, from the speech recognition output and from the input to the language generator, and to have some reward estimator that automatically estimates the user satisfaction and uses this to train the policy through reinforcement learning. And if you use reinforcement learning, you need to have a reward that's a numerical value, and the reward here that's used here is refers to the dialogue length and to a certain number of interaction quality, which is kind of a different measure for one measure for user satisfaction. And I'll show you this because it will be relevant in a second. So the interaction quality kind of is here scaled as a numerical value. Okay, so the first task is to extract the user satisfaction automatically from the system. And for that, user input, information from the user input and the system response is used. Then this is kind of extracted in a numerical, as a numerical vector for each exchange, one system, one user, one system input, one user response. And then in the original paper, there were also some temporal dimensions, which we in the next slide get rid of. And then there is a classifier that estimates the interaction quality for each turn. So in each turn, you could get a value for the interaction quality as a measure of how good was the dialogue, dialogue from the beginning of the dialogue to the current turn. And subsequently, this could be improved by getting rid of the temporal feature. So I'm not sure whether you can read this well. Here in the exchange level area, we have information about the recognition status, the confidence, whether it was a reprompt, the activity types, or the general way of what type of system action has been done, a question or a statement or things like that, and whether the system wants to confirm something. So it's more like a maybe a confirmation or disambiguation question. And then the temporal feature, which could be removed here. And then there was this, back then I thought very nice, neural network, which was using a soft attention layer, which was not the self-attention layer, which was not the self-attention you find in transformers, but something different. If you are interested, you can find the math here. So the first, there was a bidirectional LSTM, kind of doing the sequence modeling. Then there was, on top of that was the attention mechanism to get the final score through the soft conf of the label distribution 1 to 5. And this was could very successfully be employed then. You get rid of all the temporal aspects and you can really focus on the exchanges and don't need to have task-specific modeling going on with the temporal features. And the and the temporal features and the overall extended accuracy could be improved by 0.06 to 0.94, so almost 100% for this setup. Extended accuracy is the measure we chose, which means everything is viewed as correct if it's the right label or one off. So if it's just one off, it's still regarded as correct. Why did we do that? This is due to how the reward is designed. If you remember, the reward just looks at just scales the interaction quality label, taking it as a number. And if you're one off there, the reward is not that different. So we still thought this would still could still work as a good learning signal for reinforcement learning setup. Yes, and this was done with intentful cross-validation with the Lego corpus, which is Let's Go bus information system. Who in this room knows the Let's Go bus information system? 3, that's cool. Okay, 10 years ago when I was here last time, it was probably everybody. So Let's Go bus information system. That's a dialogue system that was created by the University of Pittsburgh. No, that's wrong, by the Carnegie Mellon University, which is in Pittsburgh. University of Pittsburgh is another university. So by the Carnegie Mellon University in Pittsburgh, and it was providing bus information system to actual people who really wanted to get information, wanted to get from A to B. And it was, and if you were calling the local bus services during off times, then the dialogue system picked up. And it was very unique at the time because it was a scientific system that actually was interacting with real people, which is even today is very hard within the research world, at least. Hard to do. Yes, so these are real dialogues between a system and real users from 20 years ago. I think that probably fits well. That was the training data we used. And then this estimated interaction quality was then used in the policy to train the behavior. We used a system that was a kind of state-of-the-art back then. And we simulated the interactions with different error rates. We simulated the error in the communication channel between the system and the user, what you usually would get through the ASR, through the speech level, or something you could get on different levels, 0, 15, and 30% error rates. And the evaluation metrics are task success rate and the average interaction quality. And the interesting part here was that we trained it on the Let's Go dataset, but evaluated it on all the other domains. So the task is in some way similar to find information about something, but the domains themselves were different. So Let's Go was a bus information system. Chem restaurants is about restaurants. Chem hotels about hotels in different places. San Francisco, SF stands for San Francisco. And there was also a laptop domain where you could ask about the laptops at the time from Toshiba. Yes, so it was trained on one domain, but executed on all the others, applied to all the others, so it didn't have seen the domain themselves. As comparison, we used the success reward, which was the one that was state-of-the-art back then for those domains. And the success rate for both rewards showed similar numbers. I mean, there's a bit of a variation, but it didn't really make a difference. And similar success rates for the bus information domain, where the reward estimator was trained on, but also for all the other domains where the reward estimator was not trained on. So there was some domain transfer going on, and there was basically some underlying interaction pattern for these information-seeking dialogues that could be applied here. Because if you remember, if you look at when I was talking about the interaction quality parameters that were used, the features that went into the estimator, they were not in any way related to task success. It was just information about the ASR, information about the system action, and things like that. And there was no information that was task specific, and there was no information that was domain specific, and there was no information that was success specific. So there's basically no way for an estimator to figure out what success is or not, apart from interaction patterns. And this seems to happen here. Also, for the index quality, you get higher values for the satisfaction-based reward. I mean, this is sometimes to be expected because, I mean, you train on one thing, you optimize for one thing, and so you expect to also be better there. So it's kind of a self-fulfilling prophecy, if you will. But still, it shows that for the success rate, for the success reward, you get lower rates, but you still get the same success levels for the satisfaction-based rewards. Of course, this was done in a simulation, so we simulated all the dialogues. To validate this, we also applied this to human system interactions. So real humans were acquired through Amazon Mechanical Turk to talk to the system. Oh no, I'm one slide ahead in my mind, sorry. So let's rewind briefly. We wanted to look into what actually happened, what was actually learned by those policies, because, okay, you see the numbers, but that doesn't really mean anything if you really want to know what's going on inside. So we looked at multi-objective reinforcement learning and came up with this setup where you have basically a parameter W that kind of weighs the two different rewards, the satisfaction-based reward and the success reward. And that allows, and then you can train one joint policy that kind of spans the whole dimensions from satisfaction only to success only. And you can see that satisfaction only kind of has a distribution of request, inform, and confirm acts like this, whereas more than 50% is request, but I would say almost 30% is the confirmation actions from the system towards the user. And if you move the weighted reward away from satisfaction only more to success, you see that this goes down a bit until you really only have like only the fourth of what you had when you were looking at the satisfaction only reward. Yes?
The task success was something like there was a goal.
Yes. Yes.
The policy which preferred. Oh, sorry, I forgot about Mike. So let's imagine that I have the satisfaction only policy, and there is a question from the user. I want to go to London city center.
Whatever.
And is there a connection? And it will say yes, because it will want to satisfy.
No, the confirmation is, thanks for the question. I think it's very good that I can clarify this. Confirmation doesn't mean it just confirms the user what the user says. So the user says, is this the case? And the system says yes. That's not what a confirmation means in this case. Confirmation means that the system doesn't know what your user means, and the system wants to clarify whether what the system understood is correct. So if you say as a user, I want to have a connection to London, then the system says, if it wants to confirm, I understood London as your destination, is this correct? So that's meant with confirmation here, which is something that if you have a text-based system, happens much less often, or is necessary much less often. Sometimes people kind of word things not in a non-clear way, but most of the time those things are very, very clear because it's typed. But if you have a spoken system, there is some noise in the communication channel, and there might be some things that are not clear. Place names might be one of them, but also other things that are more common words, and they kind of, to the language model, can also lead to different recognition results.
Thanks.
Yeah, so I think I should be more clear on this. Thank you very much. So request is the system requests more information from the user. Confirm is what I just explained. And inform is the system informs the user about a result. So, okay, this, as you want to have a connection to London, this is what I found. I found this train leaving at 4:57 at Cambridge Station or whatever. So what we can say here clearly is that the satisfaction-based reward favors these type of confirmation actions more than the task success-oriented one. But remember, both kind of get the same success rate. So both are successful in what they do. But you could now, of course, say maybe one is doing it better than the other. Because, I mean, both kind of reach the goal. One is doing, obviously, more confirmation acts than the other. And maybe there are other things going on. We didn't kind of look at order of slots. Yeah, that's a follow-up question. No worries.
Sorry, I want to ask about the interaction quality. The interaction quality here for like finding the optimal policy with the setting of the weight. I think the classifier was used, right?
Yes.
And have you confirmed later whether actually the ranking of the satisfaction is according the real user is preserved? I mean, like. Okay,
so you mean if real users would agree to what the estimator estimates?
Yeah.
So what we did. This is not going well. This remote, sorry. If I go back. So this is basically what you see here. This is the, no, this is not what you see here. It's just further down the way. Here. So here we have this accuracy. So we have an annotated database, which was annotated by real people. So they kind of annotated the dialogues they were looking at. And this is how well this estimator matches what the ground truth of the data set kind of gives you, which has been applied by real people. That's one answer to the question. No, that's not the real question you're asking, but that's one answer to the question. And so here you see that there's a huge agreement between what the estimator estimates and what people annotated in the data set, with the ground truth coming from them. We did not ask people to look at the simulated dialogues to see whether they kind of fit well with people's judgments, which was basically what you were asking. And but what we did, let me continue. This is already what you already know. What we did was to do the same experiments that we saw here. Sorry, I'm going back and forth. What we saw, these same experiments we did also with humans. So we had humans interact with the system. Yeah, the downside of animations is that you need to click a lot if you want to go back and forth. And here we see the same pattern. So we get the same success, not the same success rates, but we get the same success rate for both types of rewards. So as good as the success reward is, as good is also the interaction quality or the satisfaction-based reward for dialogue success. And also you get a higher interaction quality value for the success-based reward. And what's even more interesting, if we ask people what they liked better, which interaction was more natural to them, and there also the success-based reward showed significantly higher naturalness rated by people. And I think this answers your question. Yes. And this was done, as I said earlier, with mTurk people through a telephone-based experiment. I mean, I think we can all agree that this problem of finding restaurants in Cambridge or finding hotels in San Francisco is not the most difficult one, especially if you know how the database looks like. Then you find it even less problematic. But even there, you can make a difference with these very simple, in this simple setup, you can make a difference based on how the system behaves, whether it's a confirmation or it's a request. As I said, we didn't look at the order of which was asked when by the system, what was going on there. But even this simple setup, you can make a difference. So it is important. It is important what the system decides. It's not just something that should happen on the side. I think it's something we should focus on in our research. Yeah. Now I will talk a bit about the explicit dialog control for large language models, which we view especially in the context of task-oriented conversational agents. Because compared to non-task-oriented conversational agents, it kind of can remain within their own system. And if you imagine a large language model that could just remain inside, and you can interact with a large language model without any external connection, necessarily from a technical point of view, at least. Task-oriented systems always have need access to external services. I call it external services. You can call it as you want. It's just my terminology. Knowledge sources, applications, documents, anything that comes from the outside, I kind of subsume here. And there's a symbolic and non-lingual interaction going on usually. Not always in the case of retrieval-augmented generation. Of course, there are some vector-based things, but other than that, if you want to have an external service like a flight booking service that should book a flight for you, or I worked for a long time for Mercedes, where we also did in-car control. If you want to switch on seat heating, you have like the internal values for switching on seat heating, and you need to cater that service with the specific symbolic values. Otherwise, it just doesn't work. And if you extend this to many things that you find on the World Wide Web or in the real world generally, you have external things going on. Not everything just happens within the boundaries of one or many large language models. And I think this is very interesting to look at because it kind of makes it so much more difficult to do these things properly. But you all know what tool use is, I suppose. It's basically that the LLM kind of issues an API request or creates an API request to the external service or application, and then together with a response and some user input, the LLM is then again tasked with figuring out a good response, roughly speaking. And that's one way of accessing external applications or services. And the other idea is how does you use retrieval-augmented generation or things that are similar to that. So there's then like a search right after the input. There's a search step where some knowledge sources are accessed, and then some responses from those knowledge source searches are then used also as additional input to the large language model to figure out a response. And what both have in common that the LLM itself decides on what the next system action is. So if you remember the decision part that I showed earlier, this decision is kind of done within the large language model in this setup. But I think that sometimes it's really important that you have more control over the system behavior, as I tried to make the case already with the interaction quality story. In certain situations, you want to be able to control that. Maybe you have certain use case requirements where you need to kind of follow some legal guidelines. Some things need to be done before other things need to be done. Maybe you have some, if you think about therapy dialogues, coaching dialogues, and such like things. Maybe you want to adapt to the user where a certain behavior might be more reasonable to do than others. And generally, if the system behaves towards a certain goal or wants to exhibit some purpose, wants to follow a certain plan, should show some intentionality, execute some intentionality. We think that's necessary. So we want to add behavior instructions, or that's what we do basically. This is what we do research in. We add behavior instructions to the LLM input to kind of, with the hope to guide it to the right direction as additional input. This can be used coming from an external dialog controller. There are other ways of doing this, which I will briefly talk about later. But this is what we're currently looking into. And we already had a paper about that last year at SIGDIAL, which some of you might have seen there. It's not the world's most fancy paper, but it was just trying to make the point that if you want to have a specific behavior from the system, that you basically need that type of control or some type of control, and be compared to systems one where we have an external dialog controller that wants to exhibit this control over the system behavior, and one system where this is not there. We just took all the data from the database, which was not a lot because we were operating also in the Cambridge, in the multi-WOTS domains, Cambridge restaurant, Cambridge hotels, attractions. And it's, as I said, it's not the most difficult in terms of task complexity. So we could kind of take everything in here. It was not too complex, and I think it was reasonable to expect an LLM to kind of figure out what the results, what the good system response would be. So to repeat, we have this system where we have an external dialog controller that kind of creates a system action, as you would see in traditional modular systems. And we have the system without that information, just user input, of course, also the history of the interaction, and the results from the database. And this was not a real system you could interact with. We just kind of envisioned those systems, but we used the multi-WOTS data set where we had the system action and the system response and the user input and the task data, and kind of found a way of rephrasing the system action to add it to the prompt compared to not having this. And of course, the premise here is that you want a specific dialog behavior from your system. You don't want it to do just whatever, which would also be okay in this case. Maybe here you don't need a specific setup, but if you want to have that, if your task requires to have that, maybe, then this is what we wanted to look into. And we just added this blue part basically for the controlled system to the prompt. Here we have the dialog history as the prompt. As part of the prompt, we have a short introduction, and then phrase the next system response where the system wants to inform about a restaurant with the following attributes: name is Royal Spice and area is North. That is an example. I mean, this, you could probably argue that this prompt could be optimized, and I wouldn't disagree. This was just to make the point that this is possible, and if you want to do this, you should do something like that if you want to have control. And the results kind of confirmed that. We used two different large language models. One was GPT-3.5, the other one was Llama 3. And we compared the unguided and the controlled strategy. Here we used the blue score as we were really wanting to compare whether the system kind of follows exactly what the data was giving us. We wanted to kind of mimic the policy of the data set. So blue score was one of the options. And the controlled strategy kind of say, okay, this is the type of behavior we want to see from your language model. And this was having a higher match, word-based, word overlap match with the data set. Here for the Llama 3, it was even really, really horrible for the unguided case. So it's even dependent on the language model, what type of, how big of a difference that makes. Not sure whether this will continue in the future, but for those two, it was the case. But we also looked at the dialog acts that were realized. So we kind of trained a dialog act classifier to classify the resulting dialog acts, where they kind of and then compared whether they kind of match what we expect them to be. And there we also have a much higher match rate for the controlled setup compared to the unguided setup, which I think it's not surprising given the setup. I mean, it's kind of reasonable to expect that if you add additional control, you get a better match to whatever you want to control. But it still shows that if you want to have a specific behavior of your system, you kind of need to exert some type of control over your dialog behavior. So this brings us to the conclusion. With us, I mean me and my group. This brings us to the conclusion that if you want to have this type of system, you need some mechanism that's able to plan ahead. It's able to execute some plan. And this is what we are doing research on. Of course, there are other people who looked into adding some control to the system. Some people looked at task-oriented systems without additional control, still using large language models. Andre, for example. And then there's a group of people who use feed-in state behavior. So they have kind of like some external state machine, and they kind of match which state they are currently in. And based on that, they kind of figure out what the next step should be. Or they kind of phrase this within the prompt, directly say, okay, if this happens, then you should do this. If this happens, then you should do this. And this is kind of the static prompt. Or, as I said, the dynamic term-based prompts where they kind of an external match with some state machine. It's, I think the last one is going towards the direction that we're also thinking about, to have this dynamic control that you can have a term-based adaptation. Yes, so to come to the summary of my talk, I hope I could show you that system decisions are influenced by the user and influence user behavior and satisfaction, and that this kind of spans over very, very huge space of naturalness that's sorry, so short before the end. But I need to drink something. Okay. And in the second part, I try to show that even in simple setups, you can make a difference by you can make a difference by selecting the right system actions. And to realize adaptive and natural system behavior, you require explicit dialogue control. This is a list of references you won't probably be able to read, but just for completeness sake, I think it's important to show. And I want to thank the contributors. Some of them are listed here, but there are many more. Thank you very much. If you have questions, I'm very happy to answer them if I'm not coughing too much. Thank you very much.
Okay, so yeah, are there questions, comments? Yeah.
Thank you for the talk. So I'm kind of wondering about, let's say, the bigger picture and the next steps.
Mhm.
So in the last part where you can control the type of behavior the LLM should manifest when creating the response, you can also take into account some of the findings of the first part of the work, right? Like you already know perhaps what kind of a system it is, so what's the type of a preference there. But are you also planning to maybe introduce some kind of a chain of thought or like an external classifier to determine the user's preferences dynamically from the conversation and then to incorporate them back in the controller?
Definitely yes. I mean, you can phrase the overall story differently. The old problems that we had with decision-making in dialogue systems are also the new problems. Maybe how we solve them is different, maybe, but the problems are one way or the other still there. And one of the problems is exactly what you described, and that's definitely something that we potentially look into.
Thank you. Yeah, I think I might have talked to Nico about this at SIGDIAL, but I wasn't sure if I remembered it correctly.
Okay. Some other questions, comments? You look like okay.
If you can go to slide 36, I believe it is.
Yes, I can.
So I guess you had the multiples data set, or okay, right? So you had the desired responses or the intended type of dialogue item. And what I wonder is if you try to steer the response I was thinking about it from the point that probably both of the LLMs seen the data set.
That's also my assumption, yes.
Yeah. So do you know if you, or have you tried to use different type of the response than it's in the data set? Because I understood it that you followed the data set.
Yes, you follow the data set.
Okay. And have you tried to change the type and see how the numbers would change?
No, that would be,
Well,
I
like
think,
at
something
least
good.
for the match rate, would
Yeah,
be able
yeah.
to compute that.
Yes, I think that would be the logical next step.
Okay.
But we haven't done it yet. I think, but that would be necessary, kind of, to kind of make the story complete, to say, okay, we can really guide the system towards the direction we want. Yes.
Thanks.
Yeah, I guess I if I can just like quickly follow up. So basically, what you were doing with this like external control, this external control was kind of like an Oracle controller that knew what the correct type of response should be, and you essentially kind of took the LLM, and instead of like in the unguided version, the LLM was the dialogue system. In the controlled version, the LLM was kind of like just the response phrasing tool or
Yes.
NLG part of the dialogue system.
You could phrase it that way.
Okay.
I wouldn't say it was an Oracle system that knows what the answer should be. We had an Oracle knowing what the answer should be, which was the data set. But the controller was not viewed as an Oracle. The controller was viewed as some entity that was providing some instructions, which were the ones from the data set. But then the data set could be used to confirm, okay, this is what we want then.
Right. Okay, thanks. Okay. Are there any other questions, comments, anything? If no one else, I have a few more.
Sure.
So regarding the dialogue policy optimization.
Yes.
You had the interaction quality prediction, and you basically said, okay, this is the current interaction quality on a scale of 1 through 5, right?
Yes.
Did you try, or like, I'm not sure if I'm understanding correctly. Did your classifier, I mean, was it like a regression task or was it classification?
It was a classification task.
So basically you always
I
said
tried
like
regression, it didn't work.
Didn't work.
It didn't work.
Okay.
And this could be the case because, I mean, the regression kind of assumes some type of function like smoothness, let's say.
Right. Or like
but it's just categories. I mean, it's ordered, right? But it's not necessarily smooth because of that.
Right. So basically, like you tried like giving it like 2.5 or 2.7 because
Yes.
you said this like one-off thing that's there, and I thought, okay, but couldn't you make it smooth? And yeah,
Yes.
okay, so you tried it, and turns out
We tried it. Well,
okay.
To be fair, I tried it in the beginning when I started this research, and maybe I would have had a better success later when I knew more about the problem and machine learning. But I didn't try again. But for this the case where a support vector machine was doing reasonable stuff, support vector regression was failing horribly.
Right. But technically, like if you like applied some neural network, maybe it could have like figured
Yes, I mean,
out.
yes.
Yeah. Okay.
But it's not as straightforward. I mean, I think that the support vector regression kind of fails there, kind of gives you the hint that it's not a straightforward.
It's not like a linear.
Yes, well, of course not linear, but even whatever the function is, it's not necessarily reasonable to do it then, right? I mean, even if the neural network could kind of do something, does it really translate to other situations and so on and so forth?
That's actually good. Yeah. And like regarding this experiment, did you also look at the influence on the length of the dialogues that you
Yes.
got? I mean, we usually say in task-oriented dialogue that the
Shorter
shorter
is
the
better.
dialogue, the more efficient, the better. And did this prove true or no?
I don't remember.
Okay.
It was, that's the honest answer. It was not like completely out of bounds.
Right.
Or
So you
it
didn't
was
get, like, a
it was
surprising result.
within reasonable bounds. But I have to be I have to say I don't remember exactly what that was. I would need to look it up in the paper. The papers all contain that. They contain the dialogue length, the success rate, and the reward, which is kind of a combination of those. There, it's all there.
Right. Okay.
Sorry.
No worries. Yeah. And maybe now I'm asking like a follow-up on this, which you also don't remember. Do you know if like what kind of like what did you examine like what exactly influenced the people or contributed to the feeling that the naturalness or the interaction quality is better? No.
No, so there was
I
no.
wondering whether this would be like the people would feel like more secure or safe or at ease when the system is confirming more information
Yes,
towards them or something like that.
We can only speculate there. I mean, the setup didn't kind of offer that option.
Okay.
The setup was that people were phoning the system, talking to the system, and then at the end they were asked, have you found what you were looking for? They could say 0 or 1, which is success basically. Then there was a question, how satisfied were you with the interaction? 1 to 5, or I think we had even 6, so they even asked that. And then there is also how natural. I think that was how natural did you found the interaction, or I don't know if it's phrasing.
This was like part of the phone call.
Yes.
Okay.
So they were directly
People were
asked
actually, like,
afterwards.
giving you the numbers on the phone.
Yes, they were.
Okay,
Yes,
okay.
that was the setup.
Right.
When people were still thinking phoning was something people would do.
Right. I mean, yeah. Basically, we were basically doing phone experiments at
Yes.
similar time with with my PhD supervisor here.
Yes.
So
Yeah, he was also part of that. Yes.
He was also part of that.
The group, right, of the Cambridge group.
Yeah, he was also in
Part
the
of the
Cambridge
setup.
group, basically like
Yes,
slightly
before I was
earlier
there though.
than you, but yeah. So there's like the same kind of tradition, I suppose, or but okay, so that makes perfect sense. So basically, you could not ask the people for like a more elaborate answer, as in like how did you feel?
No.
Okay. In that case, that makes sense. That it's just basically out of scope.
I mean, of course, you couldn't do that like some post analysis and speculate over whatever there is.
Yeah, but it's like
it's just
probably like
same.
less valuable.
Yes.
Than like actually.
Which is why we didn't do it.
Yeah. Okay. And now I don't know, unless there's any other. Well, yeah.
Did you collect social linguistic characteristics of the people who evaluate?
No.
Yeah. I suppose it could also influence.
Yeah, but I suppose so. But I would assume that within those experiments, it's rather homogeneous. So you could probably make the statement, whatever I showed here, for those people who usually took part in these experiments. Whatever that is, I don't know, but it's probably rather homogeneous because mostly I would assume overall rather the same people in many situations.
Right. I suppose you just had like, I don't know, like US-based people or just.
Yes, it was US-based people. There were some criteria on how well they were doing. Overall, they get ratings or they get ratings on MTurk and these things.
Right. So
yes, and some people at some point we knew users who did good jobs and kind of didn't try to kind of shortcut the experiments just to get the money and things like that. Yeah.
Right.
I think it's very difficult crowdsourced experiments in this setup.
Yes. Yeah, I totally agree. Yeah.
But this could change if you have different setup with different social groups.
Sorry for like if anybody has a question, I would pass it. But I have like more of like thought or a guidance, or feel free to reject the question.
Yes.
But this is like interaction quality estimator.
Yes.
Was for the whole dialogue, right?
Yes.
Any idea how to get the easiest way the quality estimator for turn-by-turn setup?
So the labels were applied for each turn. but they represent the overall interaction up to that turn. So what you could do is to say, okay, let's look at differences. The interaction quality from the initiator goes down by 1 step. So this turn might have must have added something to the overall perception that must have gone down. But was it just this one, or was it something before that? I think for that it's not fine granular enough, the rather rigid 1, 2, 3, 4, 5 categorization. But you could look at differences. I think it's very hard to get a turn-by-turn rating for specific turns because of that effect. You never know whether it's just this one single response that kind of led to a bad value or a good value, or whether it's something that happened before and then this just added up to that. You don't see those effects. So I think it's very, very hard. And we also tried quickly, not extensively, to kind of estimate those differences. So with the data we had, at least, it also didn't go well. Then again, it was not annotated for that purpose.
Thanks.
But I think it's very hard. To have a turn-by-turn rating, I think it's very hard to really say this one turn kind of had that impact on the overall, on whatever, I don't know.
I was always thinking about it, how to like modify the policy. So it learns whether like to modify it to find out the feedback, but I never actually implemented.
And the hope is that if you have a final kind of reward for the overall interaction, and you have many interactions, that the system, the reinforcement learning system, finds out themselves what the best path is, right?
Yeah.
That's the hope. As in AlphaGo, where the system kind of learned this awesome move everybody thought was stupid, and then it was the winning move. Well, according to experts. I'm not a Go expert, I don't know. But that's what they said. So I mean, there the system kind of learned a move people thought was really stupid, but then this turned out to be a perfect move. And this is something you could in theory at least, see with reinforcement learning algorithms.
Yeah, I was suggesting that maybe there should be some action, something like, was my last response really that bad? Or like that kind of confirmation to explicitly find the feedback.
I mean,
I haven't tried it.
Yeah, I also, I mean, it's really hard to get that into a system to have then still the homogeneous reinforcement learning setup. But it would be interesting. I know at Mercedes we kind of added these types of reactions to some bad ratings from users, like they kind of swear to the system, whatever. Then you could kind of ask, hey, oh, I noticed something went wrong. Can you tell me what it was? Or so, I don't know. It was not that what they implemented. But I mean, I think this is a very interesting option you have in dialogue-based systems, that you can talk to the user and ask these things on like a meta level.
Any other questions, comments, anything? I would have one more regarding the first part of your talk.
Yes.
Because basically, when you talked about the response types or the preferred response types, depending on culture and the system being influenced by the user behavior.
Yes.
That was, sorry for making you jump.
No.
My question would be like, when you found this correlation, so basically you had like a system that was actually like not a real system, it was like a Wizard of Oz.
This was a it was human dialogue. It was not impersonating.
Okay, so these were like
actual human dialogue, but one human, well, it was in a healthcare setup, and one of the two humans was kind of having the role that the system should have.
Right.
If you had that system that was envisioned, it was part of a EU project. If you had that system, that would kind of replace that human in this interaction.
Right. Okay. So basically, like the assistant role, or in that case, like
yes, exactly.
For healthcare, it would be like the doctor.
Yeah, it was like an elderly person who needed care, but then it was a relative. The relative was kind of talking to the system to get help with taking care of this of the patient.
Right. And I suppose you haven't looked at how it actually looks in actual systems. I suppose it just doesn't occur, or that there's like no
Well, I'm pretty sure it
no
occurs.
research on that, or no attempts on that.
We didn't build, well, the overall system didn't materialize in the EU project due to many reasons. And so we don't have a system we cannot really compare.
Right. Okay. Because this will be like really interesting to see, and relates to some other stuff that we kind of planned but never really did. I mean, we have something on entrainment, on just like lexical entrainment,
Yes.
but not really like going beyond that. As in, like, someone wants concise or more direct. So this would be like a whole another level of research, I suppose.
It's very, very hard to find good methods of how to do research on that, I think.
Yeah. I guess it requires like a lot of like upfront investment, I would say. You need to build a very flexible system from the start. Yeah.
But now we have large language models.
Yeah. So it'll be possible.
It has a dialogue system that adapts to the pace of talking of the user.
Okay. So and that's they actually
It's
like a company that was founded by people who basically were involved, and they worked for IBM for a while. I guess you might even know that. And they have a company that basically now develops like commercial NLP solutions, including dialogue. And so their dialogue systems are adaptive in this way.
or at least the TTS.
Okay, so the
TTS
speech is able to like go faster or slower. Okay.
Yeah, if you go, I mean, I only talked about the communication style on the verbal level. Of course, if you go to the acoustic level as well, you have even more options.
Right. Yeah. Okay. Yeah. Thanks. I guess, are there any other comments, questions? In that case, thanks so much for the talk. Thanks for coming. It was really interesting. And I guess regarding the seminar, next week there will be a talk of Ivan Yamchikov. I think it's something related to LLMs, but I haven't checked the actual topic. So please wait for Magda's email that will definitely explain everything. Oh yeah, bottlenecks of LLMs. Okay. So I guess it will be kind of partially related to the last part that you talked about as well. Okay, so thanks everyone, and I guess see you soon.
Thanks.